Hi guys! In this lesson, I will explain the types and working principles of mechanical switches used in electrical and electronic circuits. A switch is a simple device that is used to break a circuit and disturb the flow of electrons. A switch can be either closed or open. A closed switch is on and will activate the circuit, whereas an open switch is off and will interrupt or break the circuit. Switches can be either mechanical or electronic. A mechanical switch is activated with a physical action, pressing, moving, or touching its contacts. An electronic switch is activated differently and does not need physical contact. Instead, it is activated by semiconductors, such as transistors. This lesson will focus on mechanical-style switches. Many mechanical-style switches are categorized by their number of poles, throws, and style of operation. Poles and throws are simply denoted by letters, SPST, SPDT, DPDT, for example. To better understand the working logic of switches, we need to know the concepts of poles and throws. Poles tell you how many separate circuits a switch can control. A switch with one pole can direct one circuit. Two poles can direct two circuits, and so on. Throws: how many positions can be activated by the switch. A single throw can close a circuit at one position, whereas a double throw switch can close a circuit in two positions. An SPST, or single pole, single throw switch, is the simplest form of mechanical switch. It is a simple on-off switch with one input contact and one output contact. It switches a single circuit and can either make, or on, or break, or off. An SPDT, or single-pole double-throw switch, has three terminals, one more than the simple SPST switch. It has one input contact and two output contacts. This means that an SPDT switch has two on positions and one off position. Most line switches have an SPDT configuration and are used to change over between two outputs. A DPDT, or double-pole double-throw switch, has six terminals. It is simply two SPDT switches. The switch has two input contacts and four output contacts, commonly used as on-on or on-off-on switches. A good visual example for a DPDT switch is controlling car turning indicators. Activating the switch up would turn on both the front and back car indicator in one direction. Activating the switch down would turn on both the front and back indicators in the opposite direction. A momentary double-pole double-throw switch requires the switch to be pressed or held continuously for the operation to work. When it is released, the switch will stop. For example, the switches on your keyboard. When they are released, they no longer operate. A latching switch will stay on or off until it is pressed again. For example, a light switch. Now let's examine the concepts of normally open, or NO, and normally closed, or NC. Simply, a closed switch allows current flow and is therefore on. An open switch does not allow current flow and is therefore off. A normally open NO switch has an off resting position. When the switch is pressed, it becomes a closed circuit and is therefore on. A normally closed switch has an on resting position. When the switch is pressed, it becomes an open circuit and is therefore off. Now let's examine the types of mechanical switches. This section, we will look at the most common types of mechanical switches. These are toggle switches, push-button switches, rocker switches, rotary switches, slide switches, and micro switches, to name a few. Number 1. Toggle switches. A toggle switch is a type of electrical switch that is actuated by moving a lever back and forth to open or close an electrical circuit. There are two basic types: maintained contact and momentary toggle switches. A maintained switch changes its position when actuated and will remain in that position until actuated again, such as an on-off function. A momentary toggle switch is actuated only when someone is operating the switch. A toggle switch is actuated by a lever that can be flicked into one, two, or more positions to actuate the switch, most commonly described using the pole and throw notation described in the previous section. A momentary toggle switch will spring back to the original position when pressure is released. Number 2. Push-button switches. A push-button switch causes a temporary change in an electrical circuit only while the switch is physically pushed. A spring returns the switch to its original position immediately afterwards. The push button is typically made of plastic or metal and may be flat-surfaced or contoured to the finger or hand, also known as momentary switches. The most common type of two-position switch come in a variety of shapes, styles, and materials. Pushing the button will either make, on, or break, off a circuit. The action can either be latching or momentary. A latching switch will stay on or off until it is pressed again. Number 3. Rocker switches. A rocker switch is an electrical switch that rocks back and forth and is actuated by a paddle, standard rocker, or dual rocker. A rock switch has a seesaw-type action, whereby pressing one side will rock the button in that direction and close the contacts, on. Rocking the switch back to the alternate side will open the contacts, off. Many styles and shapes are available in single-pole and double-pole configurations, for example. Number 4. Rotary switches. Rotary switches move in a circle and can stop in several positions. A rotary switch is used to control many electrical circuits with a single switch and can be designed to have many contacts happening at once on a single switch position. A rotary switch is turned in order to open or close the contacts of the switch. It consists of a moving contact which is turned in order to connect with the stationary contacts. A visual example would be the dial on a cooker. Number 5. Slide switches. Commonly have a small knob that can slide in order to open or close the switch contacts. They are very compact and easy to operate, making them ideal for small-scale projects or circuits where changeovers are required, for example, within model railways. Number 6. Microswitches. Microswitches have either a small push button or lever in order to actuate the switch. They require very little physical force in order to operate and are ideal for small-scale projects or applications. They use a tipping point mechanism sensitive to small actions. A common practical example of a microswitch in action would be within a microwave door. If the door is opened whilst the microwave is operating, the switch lever is released and the contacts are open, stopping the machine. These are the types of mechanical switches that we can encounter in many circuits. I hope it was helpful and you liked it. Hope to see you in our next lesson. Goodbye!